Today we'll talk about the introduction to data visualization. First, we will briefly discuss what is data and why do we care about data, and also about the visualization of the data. Here is an overview of what is included in this PowerPoint presentation. First is, as we mentioned, introduction to data visualization. We will briefly mention some principles, and then we'll discuss about what is data and what kinds of data there exist. We will look at some history and then about visualization of the data and graphics. So, graphical basics, details on how to make the visualizations understandable, and finally we will look at some examples of data visualizations. So what is data visualization and why do we care about it? First of all, let's talk about data itself. So what is data? So data is a collection of facts that organizations would collect either to conduct their business or to store information about their customers, about their products. It could be educational institution that wants to save information about the students, the grades, the classes, the professors. It could be a medical organization that wants to save information about their patients, medical records, diseases, categories of diseases, and medications or treatments of these patients. Data could be about meteorological data, about weather and climate. How is the climate in particular location or particular country? Data could be about, let's say, social networks. Who is friends with who on Facebook and what are their interests, what is their ages, what groups these people together, as in having gone to high school together or playing basketball together or likes to read books together. So the data is pretty much a collection of facts. It could be written as numbers or text or strings, or it could be written as pictures and sounds and videos as well. It could be written as molecular structures if it is a chemical data. So it can take various shapes and forms, but the data in itself most commonly looks like a table with a bunch of numbers and letters or strings in it. So to make sense of this kind of data would be to what we call information. So the role numbers and characters or strings would start to make sense to a human being once we do some simple analysis and try to understand its meaning. Then we can call it information. For example, these numbers and characters are describing my customers. What is the age of my customer? What is their zip code, address? What is the age of this customer? What kind of products and services they like to purchase? Now that's already information to make a difference from the raw data. And then we have something called wisdom or knowledge that is extracted from the data in the information. For example, what can I do to make these customers more profitable or to make my business more profitable? Or what can I do to heal my patients who have this particular disease? Maybe I can give them certain medications or do certain medical treatments on them. Or what can I do to make these students more successful or more engaged in the learning or more happy with their university experience? Now, this kind of analysis of the information and the data can provide us with wisdom or knowledge that we gain from the data in order to solve our problems or accomplish our goals or gain some advantage from the data. That's the whole reason why we even have data, because everybody hopes to gain some knowledge, accomplish their goals, or use the data to their advantage. So, the raw numbers, texts, and strings, and even pictures and sounds that are stored into the data can be represented in a graphical way. Or we can represent the data by visualizing it. That is, we can use charts, graphs, or maps in order to more present the data in a more pleasing and more intuitive way to a human being. If a human being is going to read through pages and pages and lines and millions of records of raw numbers and texts, human is gonna start getting tired, and data would look boring to them, or that would be very time consuming and tedious in order for human to make sense of thousands of pages of raw data. So for that reason, we want to do some more intelligent analysis on the data to discover the knowledge or the wisdom from the data, and more importantly, to present it to the human or to the user in a more pleasing, intuitive, easy to understand way. So for that reason, we need data visualization. So that is why we need the visualization. As you may have heard the old saying, picture is worth 1,000 words. We as humans enjoy looking at colors, shapes, and they just make instantly sense to our mind or brain rather than reading texts and lots of numbers and words in a page or in millions of pages. So even creating one chart or one graph out of these millions of pages would be much easier to understand and more informative to a human being, and especially to a company, let's say financial institution or a retail store that is trying to make profits or take managerial decisions based on the data in order to accomplish their goals. So for that reason, data visualization is a very important task. So the visualization is used to interpret the raw data or information and to gain insights, that is, to gain knowledge or wisdom out of large amounts of data. So we could achieve this through visual representations. Let's look at some examples of visual representations. So the raw data would be down here. Wait, you see this table. As I mentioned earlier, tabular format is common in terms of representing data. That is, many databases are in a form of tables. So table would have columns and rows. Onto the rows we have the objects or the records. They're also called tuples. Onto the columns we have the descriptions of these objects or the properties of the objects, also called features. So let's say if the objects are students, this could be on the rows. On the columns, we could have student's name, student age, student address, the classes the student is taking, their GPA. So these are descriptions of the students or properties of the students, also called features. Same could be if the objects are not students but customers of a company. They would still have their age, their address, and probably their education and maybe the products and services that they purchased. If the objects were patients in a hospital, then the descriptions again would have their name and their age and address, but in that case would contain medical exams or medical information. So many databases are in this form. Like as we mentioned earlier, there are other databases that don't necessarily take the form of tables, such as, for example, social networks such as Facebook might be taking the shape of a graph. The graph would have nodes and arrows connecting those nodes. The arrows would represent when one node or friend is connected to another node or friend. The same situation with computer networks. One computer or node is connected to another computer via an arrow onto a graphical representation of the network. In physical reality, it will be connected with a cable or through a wireless connection. So, data could come in the form of a graph instead of a table. Or it could come in more complex representations, such as a molecule, a chemical molecule of the gas or benzene that we drive our cars with, for example, would be another way to represent data, as well as the human genome, sequences of genes. Would not be in a tabular format, but will have a more complex structure representation. So, if we take this data out of this table, we would like to create a visualization of the data. One way to create a visualization is to just use the coordinate system. Have a coordinate system with x and y axis, where x would be the first attribute from our table, and y would be the second attribute from our table. So, in order to create this visualization, we would take the first number here for the first object, look at its value for x. If the value is equal to 2, then we place a little dot over here for the number 2. We place a little dot right here for the number 2. If the y coordinate, the second attribute, is also equal to 2, then 2 here and 2 here, this is where this data point ends up being. It has coordinates of 2 on the bottom and 2 horizontally and 2 vertically on the side. So this point ends up to be exactly right here where the 2 meets 2. All the other points you see here, the red ones, the orange ones, and the green ones, were positioned into this graph in the same, into this visualizational plot in the same way as we just put this pink dot right here. So the red dots, the orange dots, and the green dots were positioned onto the plot in the exact same way. That is, the number for where the dot is supposed to be was taken from the table. On the bottom we have x horizontally, and on the left on the side we have y vertically, and the value was taken from the table. So all the other numbers from the table would be represented as one dot on this visualization. Now, where is the color coming from? Why some of the dots are red, the others are green, and the others are orange? Well, that comes up to a more complex analysis. The red could be one cluster of objects. So the red ones would represent, so this is the data of Brazil. The red ones could represent a particular class of Brazilian people. Let's say these are the teenagers of Brazil. Now, the orange one could represent the orange dots would represent the working adults that are married and are now starting a family. And the green ones, for example, could represent the elderly people in Brazil. So these are three clusters that have some common property, or these are objects that are similar to each other on our plot. So by looking at this plot, we could start doing analysis of the data based on the visualization. Easy to do because the green dots are very close to each other onto this cluster, onto this plot. All the green dots are up here on the top right corner. This means these green dots have a higher values for both the horizontal coordinate x and the vertical coordinate y. They have a value of 8, while this pink one and the red ones have a value of 2 and 3. So these are the young ones. Let's say their age is 2 or 3. This one, their age is 20 or 30 years old. These ones are of age 80 or 85. All the people of age 85 will be plotted on the top right corner because they have value of 8. These younger ones of age between 0 to 35 will be plotted on the lower left corner because the values of the age are similar. And the middle ones of age 50 to 60, the orange ones, are going to be over here, right in the middle of the plot. So by looking at visualization of the data, it is easy to make this kind of analysis. So that's why it is also important to study these visualizations, because they can help us to easily make this kind of analysis. All right, so let's look at some more visualizations here. A large-scale system and events. This, as we can see here, is the cosmos or the universe, and that is a galaxy, and the galaxy is rotating. It also has this purple light coming out of its central sun of this galaxy, around which all the other suns or stars are rotating. So this right here is a visualization of astronomical data. Another visualization here is of the surface of sun. More visualizations on the bottom. On the left side, we have the impact of ball entering porous solid from the left. So we have some medical data, and again more medical data. This is more like a cardiogram of the heartbeat that was taken from patients' records. So again, the cardiogram is going to be a visualization of the heartbeat data for those probably patients with heart disease. So we can all see that it is much nicer and easier for humans to look at a picture on graphical representation or rather than looking that has colors and shapes on it. It's just more intuitive, pleasing, and natural for our brain to grasp data represented in a visual way rather than looking at a table that looks like this, that has rows and columns with a bunch of numbers and text inside of it. So that's why visualization is important with data collection, data analysis. So provides easier or cleaner way to understand patterns in the data. By looking at the visualization, it might allow us to detect or discover knowledge or wisdom that we would otherwise be difficult to discover by looking at the raw data. It also allows us to aggregate the information. So, to aggregate, let's say, all the young people of Brazil are placed into the lower left corner. Guess what? We just aggregated all of the young people into the same spot onto this visualization. If we're to look at the table, one young person will be here, another one will be here, another one will be here. It would be much more complex and time-consuming task to search for those young people into the tabular format. So this kind of data visualization is good for our learning, enhances learning, understanding, as well as reasoning. And most importantly, and the reason why it's being done more often, is to help in decision-making process, whether that is for a financial company or retail company that its goal is to create profits, or whether that is for educational organizations such as college or university, or whether that is for a medical institution that is wanting to heal patients. It does help in the decision-making process. So the data visualization can act as a link between the raw data and our understanding or analysis of the raw data. It might help the user to detect patterns and trends as we have created those clusters earlier. It might help to find correlations in the data. It might help to determine potential trajectories and outcomes that would otherwise not have been considered. So let's look at a few more examples. We have a visualization in form of a chart here using bars, vertical bars. We have on the vertical axis age and on the horizontal territory or province of a particular country. These are like states pretty much in Canada. So this helps us to show drinking ages across Canada. Here's another form of visualization. That one uses green and red lines to show trends or growths in the public sector and the private sector. So the public sector is shown in the red color and the private in the green. Again, this is Canadian statistics. Employment class of worker and their gender seasonally adjusted. Date of Canada. Yet another visualization. This one is more using a map. So we had a bar chart, a line chart, and now we have a map. So this is a map of the world. By using color, it shows fossil emissions. So it shows the grams of carbon dioxide that is being emitted by the heating in those countries. Let's look at a few more visualization examples. We could have a visualization in the form of a flow chart or a pipeline. This would show a process that is being followed. For example, collection of the data, pre-processing or cleaning of the data, mapping of the data in order to create a visualization, and the actual displaying of the visualization or image onto the screen. Here is some hand-drawn data visualization. This is a visualization of architectural data, city streets and buildings into the city. And this again is a map that is showing territories, lands or rivers. Visualization of plants on their roots and their leaves. This is similar to the very first one that we have seen with X and Y axis or a coordinate system. That is horizontal and vertical axis, and the data points are represented as points onto the coordinate system. So we could use points. They could be smaller points or bigger points. Or we could use specific shapes such as circle, rectangular, diamond, or triangle. The lines, they could be solid lines or dotted lines, or they could be more thick or more thin lines. We could also use colors. So we have the position, the shape that we place into the position, the color, and the line. So these would be the basic structural elements for creating a data visualization plot. So position would be onto the coordinate system somewhere. The place comes from data that is in the table, as we have seen earlier, 1, 2, 3, 4, and so on. The shape, as we mentioned, circle, rectangle, diamond, or triangle, and then its color. Here we have just lines and colors. And here we have a grid or a matrix. This is pretty much how a picture is represented in the computer's memory. It divides the picture into pixels or points, and each point inside of this matrix has a number that represents the color of the point. So over here we have a picture of resolution 4 on vertical, 1, 2, 3, 4, 1 by 12 on horizontal from January to December. So this picture will be 4 by 12 pixels if this was to be represented in computer memory. This is also showing the temperatures in particular cities, as you can see Chicago on the top, and then it's more cool, so that's where you see the bluish or violet colors. And then we have California Death Valley, which is the hottest place in the world, where we have more of orange and yellow colors, where the yellow is nearly 100 degrees in temperature. So we could use colors, shapes, lines, or a matrix as in terms of a map to create the data visualizations. So that is all that we have today for introduction to data visualization.